This is the video lesson for Introduction to Friction. The learning target for this lesson is, I'm learning to describe kinetic and static friction between two surfaces. The success criteria for this lesson are, I can define kinetic friction as the force that resists the motion of two surfaces sliding against each other. I can define the magnitude of the kinetic friction force as the product of the normal force and the coefficient of kinetic friction. I can define the static friction as the force that prevents two surfaces from sliding against each other when they are at rest relative to each other. I can explain how static friction adjusts its magnitude and direction to oppose the applied force up to a maximum value. And I can understand that the coefficient of static friction is typically greater than the coefficient of kinetic friction for a given pair of surfaces. So what is friction? Friction is a force that opposes the relative motion between objects that are in contact with each other. So here you can see a diagram where you can see zoomed into these two objects, a crate and a table or a floor, and you can really see how craggy and jagged the surfaces are. So friction arises due to the roughness of the surfaces in contact, as you can see in the diagram, and due to the attractive forces between molecules making up the two objects, so that even perfectly smooth surfaces are not friction-free. So this is because of the attractive forces, again, between molecules making up two objects. So this is as opposed to the repulsive forces between the electrons that make up surfaces that causes the normal force. So what determines the strength of the force of friction? So the magnitude or strength of the frictional force has two forms. It has static friction when objects are touching each other but not moving, which the equation for static friction is actually an inequality. So the force of static friction is less than or equal to the mu sub s times n. So static friction is less than or equal to the coefficient of static friction, which is mu sub s, times the normal force, which is n. So continuing our discussion of what determines the strength of the force of friction. So once the force applied to an object reaches the upper bound of the static frictional force, mu sub s times n, the object begins to move and a different type of frictional force takes over. So that other frictional force is kinetic friction. So this is when an object is moving relative to another object. So F sub k, the kinetic frictional force, is equal to mu sub k times n. So kinetic friction is equal to the coefficient of kinetic friction, which is mu sub k, times the normal force. So the coefficient of friction, mu sub k or mu sub s, is determined by experimentation, and it depends pretty much solely on the material itself. It doesn't depend on how big the material is, but basically it depends on what the material is made of, what the surface is like. Is the surface craggy or is it smooth? What is the material like? All of that information goes into determining what the coefficient of friction is. So a qualitative example of friction, my kids love it when I drag them around the house in a laundry basket. So kids get in the laundry basket, they both weigh between 30 and 45 pounds. So I've got like 60 to 80 pounds in the laundry basket, and getting the laundry basket started pulling, so getting it to start moving is really difficult. It takes a lot of force to get it moving. That force that it takes to get started is overcoming that static friction force. But once I get it moving, then it's a lot easier to keep it moving. And that force that is necessary to keep it moving, that I'm just overcoming the kinetic friction force. So typically the static friction force is a lot heavier, a lot bigger than the kinetic friction force. So static friction, a lot bigger usually. The coefficient of the static friction is usually larger than the coefficient of kinetic friction. Okay, let's look at a quantitative example on how to solve friction problems. So a 5 kilogram block is resting on a horizontal surface with a coefficient of static friction of 0.4 and a coefficient of kinetic friction of 0.25. A horizontal force of 15 newtons is applied to the block. So we want to A, calculate the normal force acting on the block, determine the maximum static friction force that can act on the block, calculate the kinetic friction force acting on the block, and then determine will the block move under the influence of the applied force. All right, so the first thing we're going to do is draw a free body diagram. That's the way we start that's the way we start to solve pretty much any free force problem. Okay, so first we have the gravitational force. So Fg is m times g, which is equal to 5 kilograms times 10 meters per second squared. So this is equal to 50 newtons. The normal force, in most cases, is going to directly balance the gravitational force. So the normal force is 50 newtons. Then we're going to have the applied force. And that is 15 newtons in this case. And then we have the friction force, which we're not sure what that friction force is yet. So that's our free body diagram. So calculate the normal force acting on the block. So that's A. So our normal force is 50 newtons. Okay, so question B, determine the maximum static friction force that can act on the block. All right, so we have our normal force of 50 newtons. Static friction force, F sub S, is less than or equal to mu sub S, so this is the coefficient of static friction, times the normal force. So the most that the static friction can be is the coefficient of static friction times the normal force. So we can say that F sub S is going to equal 0.40 times our normal force, which is 50 newtons. So 4 times 50 is 200, decimal point scooted over, so our maximum kinetic friction is going to be, our maximum static friction is going to be 20 newtons. Okay, so for part C, calculate the kinetic friction acting on the block. All right, so our kinetic friction equation is mu sub k, so that's the kinetic friction coefficient, times the normal force. So we have kinetic friction is equal to 0.25 times 50 newtons. So that's a quarter of 50. So that's going to be 12.5 newtons. All right, so that is our kinetic friction acting on the block. Okay, so question D, will the block move under the influence of the applied force? Okay, so now we have to figure out the sum of forces in the x direction and see if the static friction is able to, if the static friction is small enough to be able to move the block. So we have the sum of forces in the x direction is equal to, so our applied force is 15 newtons minus our static friction. And the question is that equal to an acceleration? So you can see that the static friction force, 20 newtons, is larger than the applied horizontal force. So we can tell already that the block is not going to move. So this number is larger than this number. So we're going to have a negative force. So if we imagine the block here, and we imagine that we're applying a force, but the friction force is pushing against, is working against that that force moving, pushing the block to the right. So this is the static friction. So that static friction force is opposing the applied force to get the block moving, and the static friction is too strong for this particular applied force. We would have to have a force of greater than 20 newtons to be able to get the block moving. Once the block was moving, we would have an acceleration, because the applied force of 15 newtons is greater than the kinetic friction force. But because the static friction force is less, or the applied force is less than the static friction force, we are not going to move the block. So here's some interesting questions to ask yourself if you knew about friction. So did you know without friction a car couldn't drive because the wheels would have no grip? A rolling wheel has static friction because it isn't sliding. A locked wheel, on the other hand, has the lower kinetic friction, which is exactly why cars have anti-lock brakes. You want those wheels to be rolling and not sliding. Formula One teams spend tens of millions of dollars on aerodynamics to push the car into the track to increase the normal force, thereby increasing friction. Okay, so what have we learned in this video? We've learned that friction resists motion. So friction is the force that resists the motion of two objects sliding against each other. We've learned that the normal force times the friction coefficient is how you calculate friction. So friction is calculated by multiplying the normal force by the coefficient of friction. So this is either the static coefficient of friction or the kinetic coefficient of friction. And static and kinetic friction are two different types of friction. So static friction resists objects sliding while at rest, and kinetic friction opposes objects sliding against each other. All right, thanks everybody.